Okay, listen up here. Yesterday, we went over the 5 types of chemical reactions. Okay, we went over synthesis reactions, which are 2 elements reacting to form a single compound. We went over decomposition reactions, which is a single compound breaking down into its elements. We went over combustion reactions, where a hydrocarbon, that is a compound containing carbon and hydrogen, burns in the presence of oxygen to produce carbon dioxide and water. We also went over the 2 types of replacement reactions. Single replacement, where an element reacts with an ionic compound, and double replacement, where 2 ionic compounds react. Okay, we had gotten to the point yesterday where we were being given reactions like these and being asked to identify the type, write it in words, and balance the reaction. All right, so I'm going to walk through the first one with you here and then have you try a couple just as a bit of review, and we'll walk through the rest of them together as well. Okay, so our first one, we've got a single compound, and on the other side, on the product side, we've got 2 elements. So what kind of reaction is that going to be? Decomposition. All right, so our first one is a decomposition reaction. Okay, then I've got to write it out in words. Is this a molecular or ionic compound? It's molecular, so I'll need prefixes. This stuff is trinitrogen dioxide. Okay, and then, okay, we're breaking down into, what would I call this stuff? Nitrogen. Just nitrogen, right, it's an element. Okay, it's one of our special elements because it comes as a pair, and same with oxygen. Now I have to balance. What should I start with when I balance? The biggest number, because it's not a combustion reaction. They have their special rules. Okay, so I'm going to start with my largest number, which is nitrogen. I've got 3 on this side, and I've only got 2 over here. What's the only way I can make those equal? Multiply them. Right, to make what's the lowest common multiple? 6. Okay, so I'm going to put a 2 here. That gives me 6 nitrogen on this side. I'm going to put a 3 here, which gives me 6 nitrogen on the product side. Putting this 2 here gives me how many oxygen? 4. All right, what do I need to put here to get 4? A 2. All right, and now I'm done. What if I made a mistake first off, and I thought, oh, maybe this should be a 4. Okay, if I did this and said, okay, now there's, all right, 6 here, and then 4 times 2 is 8, 4 times 2 is 8. That's balanced. But can I leave it that way? I need to reduce it. Okay? Anytime you come up with balancing numbers, if they're too large and you can reduce them, reduce them. Okay? Doesn't happen very often, but once in a while. Yep. Just in case I had guessed wrong. Instead of thinking that I could make it 6, I thought, oh, 12's the lowest common multiple, so I put a 4 there. Okay? I was just saying, if I made a mistake and said I needed a bigger number, when I got done, I would look at this and go, oh, I could divide all of those numbers by 2. I picked too big a number. Because there's 4 here. 4 times 2 is 8. 4 times 2 is 8. Okay, this isn't the right balancing. I'm saying if I made a mistake and picked too big a numbers, I could look back at this and go, oh, I have to make those numbers smaller. Okay, all right, I want you guys to try 2 and 3 for now. Okay, let's just do 2 and 3 for now. So on number 2 here, I've got calcium, which is an element. It's a metal, but it's an element, reacting with iron 3 chloride, which is an ionic compound. So what kind of reaction am I looking at here? Not double. Single replacement. If it was double replacement, I'd have 2 ionic compounds. In this case, I only have 1, so that's single. Okay, single replacement. All right, then I got to write it out in words. So I have calcium reacting with iron 3 chloride, producing iron and calcium chloride. Okay, so if I gave you a question like this on, let's say, a unit exam, okay, it would go something like this. You'd get a mark for the correct reaction type, a mark for having the reactants written correctly, and a mark for the products written correctly, and then you get another mark for balancing. So this would be like a 4-mark question. So to balance this, I'm going to start with chlorine because it's present in the largest number. 3 on this side, 2 on that side. Lowest common multiple is 6. All right, so I'm going to put a 2 here and a 3 there. The 3 gives me 3 calcium, so I've got to go back over here and make sure I have 3 calcium. This 2 gives me 2 irons, so I need to make sure there are 2 irons over there. All right, questions on that one? Okay, what kind of reaction is number 3? It's a combustion reaction. All right, so there's special rules for a combustion reaction. Now, this one's going to be hard to name because I didn't tell you what the prefix was for 14, and quite frankly, I don't know what it is. Okay, in this case, this stuff is actually called hexane, but I would never give you one. You wouldn't be able to name with the prefixes from 1 to 10. Right, so next time if you get one on a test or a quiz, the hydrogen won't be bigger than 10. Now, my rules are balance alphabetically, and what's the other one? It is something to do with the carbon. Right, if I have an even number of carbons, start with a 2. Do I have an even number of carbons? Okay, so the rule of 2 applies. All right, 2 times 6 is 12, so I need to put 12 carbons over here. 2 times 14 is 28. And 14 times 2 is 28. So now my hydrogens and carbons are balanced. Now I've got to look at my oxygens. 2 on this side, and on this side I have 24 here, plus another 14, for a total of 38. Okay? Everybody with me on that? All right, 38 divided by 2 is 19. All right, written out in words, we've got hexane plus oxygen gives us carbon dioxide and water, and this is a combustion reaction. Okay, questions on that one? Okay, I want you to try those 3. Obviously, this one works a little bit different. Now I'm giving you the reaction in words. You're going to have to write it out in formula form. All right, so number 4, I've got chlorine, which is an element, reacting with lithium, which is also an element. They're producing a single compound. What reaction type is that? That's a synthesis reaction. All right, then I need to write it out in words. So chlorine plus lithium gives us lithium chloride, which is an ionic compound. All right, in order to balance this, balancing is going to be pretty straightforward, right? I only have one thing that's out of balance right now. Okay, so I put a 2 here to balance the chlorine, but that'll give me 2 lithium, so I've just got to go back and put a 2 in front of that. All right, and we're done. Okay, how many people are done number 5? All right, I'll give you a couple more minutes on 5 then. So with number 5, I've got magnesium fluoride, which is an ionic compound. And it's reacting with cobalt nitrate, but this is a multivalent metal. It has more than one possible charge. In this case, it's cobalt-3 nitride. And that's going to give us magnesium nitrate and cobalt-3 fluoride. You would be surprised how often on a test someone will remember to put the 3 on this side and forget it on that side. Okay, it can't change. If it's cobalt-3 over there, it's cobalt-3 on the other side. It'll never switch from 2 to 3. Okay, but you got to have the Roman numeral on both sides. But it happens a lot that people forget to put it on both sides. So don't forget to put it on both sides. All right, these are all ionic compounds. So what kind of reaction is this? Double replacement, right? What should I probably balance first? Biggest number, which could be nitrate or fluorine. They're both a 3 at least in one position or another. I'm going to start with nitrate. Right? There's 3 on this side and there's 2 over here. So a 3 here will give me 6 nitrates. A 2 here will give me 6 nitrates. This 2 gives me 2 cobalts, so I've got to go over here and make sure my cobalt balances. When I do that, it gives me 6 fluorine. So I got to go back over here and make sure I've got 6 fluorine, which, as we said, makes the last thing fall into place. So it's a good sign we've done it right. Harlan. On this side here, because I was balancing the nitrate. Okay, on this side, there's 2 times 3 is 6 nitrates. No, I put this one here first. I looked here and I said there's 3 nitrates here and 2 over here, the lowest common multiple being 6. So then I made this one equal 6 and this one equal 6. Okay, so I put a 3 in front of this compound to give me 6 nitrates. Then I went back over here and made sure I had 3 magnesium on this side. Okay, so you're always going to be jumping back and forth when you balance. When you balance one thing, you got to go and check that what it was attached to is still balanced. Okay, that's why I kept going back and forth. How many people have done number 6? Okay, so let's look at 6. This is the first one, and these are tougher. Okay, when I give it to you in words, that's going to be tougher than when I give you the formulas. So for this one here, I've got copper 2 nitrate. So copper with the 2+ charge is with nitrate, and nitrate's a 1-. So this compound is going to need what? Brackets. That's going to react with magnesium. So just magnesium. Okay, it's not bonded to anything. What kind of reaction is that going to be? Single replacement. All right. This is a metal. Magnesium's a metal, so it's going to replace what? Copper. Right? And that's what they have. It says to form magnesium nitrate. Right? Magnesium is a 2+, nitrate's a 1-, so it's still going to be a 2 over here. Right? Plus copper. Right, so now I've written it out correctly, and again, same logic would apply here. You would get 1 mark for the reactants, 1 mark for the products. Okay, what kind of reaction is this? We just said, sorry, single replacement. Okay, so it's a single replacement reaction. That would be a mark, and now we've got to balance the whole thing. Looks good. Okay, how do I know it's good? Well, I mean, I just kind of went through it quickly, but there's 1 copper over here. There's 1 over there. There's 2 nitrates and 2 nitrates. 1 magnesium, 1 magnesium. I don't have to do anything. Right? Everything's already equal on both sides. Questions on how that one works? Okay. All right, try those 2. So for number 7, okay, we've got C12H26 reacting with oxygen gas. All right, so C12H26 plus O2. Remember that oxygen gas is O2, not O. Right, it's one of our special elements. What kind of reaction is that going to be? It's going to be a combustion reaction. So the products are always carbon dioxide and water. Okay, what are our special rules? I have to balance in alphabetical order. Do I need the rule of 2? Yes. All right, 2 times 12 is 24. So I need to put a 24 in front of the carbon. 2 times 26 is 52. 26 times 2 is 52. Okay. All right, now I got to look at my number of oxygens. So I've got 48 oxygens here. Okay, plus another 26 here for a total of 74, right? Everybody with me there? All right, so, right? Yeah, 74. That's right. Okay, so what's 74 divided by 2? 37, right? Okay, so I need a 37 there. Okay, it's just one of those things. That's the tricks, right? When I give it to you in words, these are the things you have to remember. Is that element special? Does it need a 2, an 8, a 4? These are all things that we want to make sure we check on our periodic table. How many people have done number 8? Okay, let's look at number 8 as well then. All right, so we got lithium nitride breaks down into nitrogen and lithium. So if it's breaking down, what reaction type is it? Decomposition. All right, so lithium nitride, Li with N. Now this is an ionic compound, so I've got to do my drop and swap. This is a 3 minus, this is a +1, so we're looking at Li3N, and it breaks down, so that means we go straight to the arrow into nitrogen and lithium. Are either of those special? Nitrogen is special, comes as a pair. Right? These are the things we got to check, right? It's easy to forget these things, and then not only will we get the reaction wrong, but will we get the balancing right? Well, you might get it to balance, but it won't be right because you won't have the right reaction. So it's very easy to lose half the marks on a mistake like that, right? We don't want to be looking at making those kind of mistakes. All right, usually we start with the biggest number, but if I do that and just put a 3 over here, I'm going to have to change it right away because there's a 2 on my nitrogen. So I'm going to start with the nitrogen instead and put a 2 here to balance my nitrogen. How many lithium does that give me? 6. And then we're done. Okay? And of course we would write that this is a decomp reaction. All right, there's 2 left. I want you to try those last 2 there. So with number 9, I've got hydrogen sulfide. So that's going to be hydrogen with sulfur. This is an ionic compound because hydrogen's listed first. Hydrogen's a +1, sulfide's a -2, so we're looking at H2S. And it's reacting with calcium hydroxide, so Ca, which is a 2+, and hydroxide, which is a -1, which means this is going to need a 2 and brackets. Going to need brackets. Okay, all right. In this reaction, then we've got what kind of reaction? Double replacement. These are both ionic. Okay, so in the double replacement reaction, they swap metals. So we've got calcium sulfide and we've got water. Now, if I have in a reaction on one side hydroxide, like I do here, and I have water on the other side, I write water as HOH. The reason for that is it's easier to balance that way because I can track better where everything came from. If I write it as H2O, I might forget where one of those hydrogens came from and misbalance. All right, double check my drop and swaps here. This is a +2, this is a -2, so that compound is okay the way it's written. +1, -1, so that compound is also good. Now I need to balance. On this side, there are 2 hydrogens. How many over here? There's just 1, because this hydrogen is part of OH. That's why I write it that way, so I don't get them confused. There are 2 hydrogens here and only 1 here. So I'm going to put a 2 there. When I do that, that gives me how many OHs? 2. And over here there are 2. All right, 1 calcium, 1 calcium, 1 sulfur, 1 sulfur. That was the only number I had to add to make it balance. Luke. Only if it's by itself. Hey, how many people are done number 10? All right, number 10 is an example of that, except it's with phosphorus and not with sulfur. Okay, it says phosphorus reacts with oxygen. Phosphorus is one of our special elements. When it's by itself, it's a 4. Right? In a compound, it can be whatever the prefixes or the swap and drop dictate. And it's reacting with oxygen, which is also special, O2. And that's going to produce triphosphorus dioxide. Okay. What should I balance first? Phosphorus. Yeah, it's present in the largest number. What's the lowest common multiple of 4 and 3? 12. All right, so I'm going to put a 3 in front of this and a 4 in front of this. When I do that, it gives me how many oxygen? 8. So what needs to go back over here? 4. 4 times 2 is 8. Okay. All right, what kind of reaction is that? Synthesis reaction. Okay, where we're headed eventually with this is that I can give you just the reactants and you predict the products. Okay? It's patterned, so it's not hard to do. It might sound intimidating right now, but we know that in a synthesis reaction, if I have two elements, they're going to go together to form a compound. It wouldn't be hard to figure out what that compound is, right? And we know in a double replacement reaction, the products are just the metals swapped, okay? Things like that. So there's always a pattern. Predicting the products is actually not all that difficult. All right, so in your workbook you'll see this, well, it doesn't have the handwriting on it, but okay, it looks sort of like this in your digital workbook. I would like you guys to try 1, 2, and 3 before class ends. I'll call it up in your workbook here. Okay, and that question was, how do I know which iron this is on this side? And the answer is you don't, nor do you need to, because it isn't iron 2 or 3 yet. Right now, iron is an element. It doesn't have a charge when it's by itself. Over here on this side, it does, because now it's in an ionic compound. It is here that I have to decide whether it's 2 or 3. Right? But over here, when it's an element, it isn't 2 or 3 yet. It hasn't lost any electrons yet.